everyone. For those who don't know me yet, my name is Rodolfo Marcos. I am a data engineer with 10 years of experience, and I'm here to help you understand data concepts in an easy way. Today, we're going to talk about streaming data. In this case, we're going to use PySpark, and I will show you some code. We're going to do some playground and study concepts as watermark and kinds of window functions that we can use at streaming. So let's start playing. Right. So when we talk about streaming, it basically is a sequence of events that occurs within a timing interval. So in this simple example, we have like this squares represents events in a system. It can be anything. It can be the velocity of a vehicle. It can be the values of purchases or any metric that you're working with. And it happens along the time. So in this example, the first value is 10 and the last is 8. And before we start, please take a look at the project repository in Github. It has all the instructions on how to run it locally. You can download the code, and you can find the link for the repository below. Let's take a look in what we're going to build. Our processing system is composed of some components. The client that will be sending the events to the event receptor at the server side. The event receptors will save events as JSONs in our file system that will be ultimately read by the streaming processor in PySpark, generating our results. These results can be outputted in many different ways as table, reports, files, feed AI models, or trigger some rule on monitor systems. If you notice here, our event receptor, we can have many instances of it. Because when we think about distributed systems and volume, we can have multiple event receptors receiving events from different clients distributed in different regions, and all of the events is centralized in a single file system. So that's on purpose why we have event receptors separated from the streaming processor. Let's start generating events in our playground. So first thing that I'll do is to start our process. All right. So I'll start both the Python processing script and our server. All these functions is in the README file. Then I will open our event simulator. And the way I configure it to get started is to calculate the average for the events that happens within a 2 seconds window. So I will start our simulator, and it started sending events, and in a few seconds we will have some results. Our event stream ran for a few seconds, and we already have some results. I stop it here to stop generating the events, and then we can see for each 2 second window what was the average. For example, the last one here, the last square, which was for the first event, between 56 and 58 seconds, the average was 9. And this is probably before this event here that I'm pointing with the mouse. Then it went 7, then 0, then 57. So you may be wondering why most of the values are the same. Because it's calculating the average for every 2 seconds, and the event is being generated also every 2 seconds. In our Spark stream, which is where our processing is calculating the average, the way it's configured is to read all the events that we are saving in the input stream folder. In our case, this input stream folder is what represents the file system here, but it can be from other sources that you can choose that are compatible with PySpark. And then when it reads the events, it does a watermark of 2 seconds, a group by of 2 seconds as well, and it's calculating the average and routing by 2 decimals. So just to give an overview of what this is doing, we'll go into details. All right, so we took a look at the code, and now let's understand more some concepts. In this slide, we are aggregating, we are summing data for every 3 elements. If these elements happens every 1 second, so we'll have the first aggregated value as 30 as the sum of 10, 5, and 15, and so on. But what happens if, for example, let's say this 5 can arrive late at our streaming process. What we do is to use a watermark. A watermark is basically an interval that can be set in seconds or minutes, and that is the maximum allowed late arrival time for a given element. Basically, in practical terms, is an interval that is delayed before the window starts being processed. So let's say if this 5 example, it arrives late, our process will wait this watermark interval to start processing the sums for each window. This will give some extra space for our late arriving data. Be aware that short watermark intervals will make it faster to get a response for a real-time system, for example, but it will not guarantee that elements that will arrive later than that will be processed. However, on the other hand, long watermark periods will guarantee that more delayed elements will be processed, but the system will have more delay to actually have the results from the aggregated data you're working with. Another important concept to understand is the window types you can use to aggregate the data. In our example, we are using fixed windows. This guarantees that no overlap is happening between the elements that's been received. So when we sum these 3 elements, we stop and we start summing the next 3 elements. But we can also have the option of using sliding windows, which allows you to have some overlap of the elements we are processing. So it's important to understand watermark and window types so you can think of what will be the best solution for the business needs of the system you are working. For example, using these aggregated functions, you can set alerts for maximum vehicle velocity. Let's say you have sensors in some cars, and every time in a given interval, a car is more fast than 100 kilometers, you're going to send an alert. Or if you are monitoring some transactions in a system and you don't want it to be zeroed. So you just need to understand how to tune window sizes, the type of windows, and watermarking, taking into considerations your specifics. We understood what is watermark, window types. Let's look at the code where this is set. In our sparkstream.py file, we have here the watermark, how many seconds we are allowed to handle late data, also the time of the window, in this case is 2 seconds, and what's the aggregated function we are applying. In this case, we are doing an average, but we can do sum or max or anything. There is some comments here to help you explore and change it. So I'll be changing here just for sake of example. I will keep the watermark for 2 seconds, then I will group by the windows in 10 seconds, and instead of doing an average, I will be summing the data. I will save, then I will turn down our servers, both the server and the streaming one, and start it again. Right, so if you're running it locally, in intervals where you stop and start it, before you start it again, just delete this checkpoint, input string, and output string folders you have that's created locally, so it resets the stream. I just restarted our process, and let's start sending events again. So remember, this time we want it to be summed in a 10 seconds window. Alright, so our process run, and you can see here that it's summing all the elements in a 10-second window. So as you can see here, it's summed as 222 for events that happen between 40 and 50 seconds for this hour and minute, and did it all for other all windows as well. Alright, let's take a look at our server. In our architecture, it both receives the events saved in the file system for the Spark processor to read, but it also has an endpoint to read the result that's generated from the PySpark as well. So it's missing here an arrow connecting the output to the website client, but let's take a look at the code. So here, as you can see, this is the endpoint to get the aggregated data, no matter if it's max, min, average, or sum, and the endpoint to receive the event. In this case, it's receive the event, checks if it has the event time and event value, and save in the input stream folder. So basically, our server is used to receiving the events from our client and getting the results that our PySpark is saving in the output folder and returning it back to the client so it can be shown as the results here. So thank you for staying with me until the end. I hope this can be helpful to you to understand these concepts or doing some tests on your own. And I always try to be very didactic in the things that I build and the way that I explain. So thank you again, and I'm open to questions or if you have any other ideas of what to learn.